Chapter 4, Exercise 3.6. In each of the following cases, tell the direction of the acceleration vector. A stone was dropped from the top of a cliff. It is falling down towards the ocean. Neglect air drag. So the only force acting on that stone is the force of gravity. When the only force acting on an object is the force of gravity, by definition, the stone is in free fall. In that case, we know that the acceleration is equal to g, which is negative 9.81 meters per second squared, j hat. This is true for any falling object if we can neglect air drag. B. A stone is thrown upward from the top of a cliff, then it falls in the ocean. Again, we neglect air drag. Because we neglect air drag, it's again a case of free fall. Now, on the way down, most students would tell you that the acceleration is negative 9.81 meters per second squared. The question is, how much is the acceleration on the way up? And to a lot of students, the acceleration should be different because the stone was thrown by a hand. So what you have to do is break down the problem into two different physics problems. First one, you throw the ball. So you have an upward force, the force of the throw, and then you have Fg down. And in order to throw the ball into the air, the force of the throw should be larger than Fg. So the magnitude of F should be more than the magnitude of Fg. And in this case, your acceleration is up. Second part, now the stone is not touching the hand anymore. So the only force acting on the stone is Fg. And the way you represent the momentum given to the ball is by saying that the ball has an initial velocity. So you have an object with an initial velocity and a force acting downward on it. Therefore, the stone will slow down. So you can tell the acceleration is down. The acceleration should be opposite to the velocity because the object is slowing down. Since the only force acting on that object is Fg, the net force is Fg. This is a case of free fall. Therefore, the acceleration is negative 9.81 meters per square second, j hat. So the conclusion is that the acceleration is always the same. Whenever you have free fall on the way up or on the way down, the acceleration is always down. As for this part of the problem, usually this is not the concern of the free fall question. So try not to think in terms of the initial throw. Question C, a tennis player hits a ball with a racket. So initially the ball is arriving this way, and then the racket hits that way, and then the velocity changes direction, so this is your v2. So in that case, the acceleration is going to be in the same direction as the net force, therefore it's going to be this way. Remember that according to Newton's second law, the sum of the forces and the acceleration are always in the same direction. Last question, D. A boy kicks a soccer ball. This is exactly the same as C.